Assalamu alaikum and a very good afternoon to all of you. I hope that all of you are fine. I'm Munis Zahir, and in today's lecture I will discuss three things. First, we'll discuss distance to the visible horizon, and then we will discuss backside and balancing backside and foresight distances. We also discuss about the reciprocal leveling, and in the last we will do some numerical problems also. So let us start with the topic of distance to the visible horizon. So as you see in this diagram, let C be the point of observation at an altitude h. This means that the observer in the sea is at a height of h meter above the mean sea level. And A is the point on the horizon. Horizon is a point at which the sky appears to be meeting the water surface. So the distance to the visible horizon A from the point of observation is obtained by this formula. We have already derived this formula when we discussed about the curvature and refraction correction. That is the combined correction. H is equal to 0.0673 d square. Please remember that this d is always in kilometers. So from this relation, we can easily calculate the distance d, that is equal to square root of h over 0.0673. Now suppose that if you neglect the reflection correction, then h comes out to be 0.0785 d square. So from this, we get the value of d as square root of h upon 0.0785. Now this is equal to CA, the distance to the visible horizon from the point of observation, which is always taken in kilometers. And h is the height of point of observation above the mean sea level. Now come to the topic, that is what is the meaning of balancing backside and foresight distances. So there are basically three types of errors which can introduce in any staff reading. The first one is due to curvature, second is due to refraction, and third one is due to collimation error. That is, the bubble line is not exactly parallel to the level line. So here in this diagram, you will see that suppose that the line of sight is inclined at an angle of alpha. So this means that we have certain error in the star reading. That error is equal to A1 on point A, and on point B it is B1. Okay. Now here in this case, the instrument is set up exactly midway between the 2 points A and B. So the distance from the instrument to the point A is D, which is same as the distance from the instrument to the point B also. So here in this case, when you have to find out the difference relation between any 2 points from a single setup, so the error due to collimation, the curvature, the reflection may be eliminated if the length of the two sides are made equal. So this means that is the instrument is exactly in the middle. So whatever be the errors are there, okay, that I told you that there are three types of error: there due to curvature, due to reflection, and the collimation. So the error in the staff reading due to these three effects will be eliminated if you put your instrument exactly in the middle. How it is removed? So we'll discuss now. So suppose that observed staff reading on A is A1, capital A1. That is the observed staff reading. Okay, and a true staff reading is capital A small a. So true staff reading means from here to here, with the line of sight exactly horizontal. Similarly, observed staff reading on B is B1, and true staff reading at B is BB, that is capital B small. So this means that errors are, this is the amount of the error, A1 and BB1. So therefore, true reading will be how much? True reading will be equal to A1 minus the error amount. So this is equal to AA1 minus this one is your error, AA1. So this is nothing but AA1 minus, now this angle is alpha here and this is your D. So we can apply trigonometry here. So this distance AA1 is equal to D times tan of alpha. Similarly, the true reading at D is equal to BB1 minus D times tan alpha. So this means that the true reference of level between A and D is given by difference of the two staff readings. So that is equal to BB1 minus D tan alpha minus AA1 minus D tan alpha. So here you see that D tan alpha cancels out and finally we get BB1 minus AA1. So that is nothing but the, it is nothing but the difference of the apparent staff readings at the 2 points. So this means that the error is completely eliminated by equalizing the backside and foreside distances. So this means that if your instrument is not exactly in adjustment, it is out of adjustment, line of sight is inclined either up or down. And in that case, if you are using the same instrument, if you have to find out the correct difference in elevation between the 2 points, then you have to set your instrument exactly midway between the 2 points. By doing so, all the errors are automatically eliminated. Now let us come to the next topic, that is your reciprocal leveling. What is the meaning of reciprocal leveling? Let us first discuss this one. So this is nothing but the operation of leveling in which the difference in elevation between 2 points is accurately determined by 2 sets of reciprocal observations. Now last time we discussed that if you set your instrument exactly midway between the 2 points, then errors are automatically eliminated. Now in some situations, it is not possible to set your instrument midway between the 2 points. Suppose that we have a wide river in between the 2 points. So we are not able to set the instrument exactly midway between the 2 points. So in that case, we have to perform a special type of leveling that is called reciprocal leveling. So it is employed to determine the difference in elevation between two intervisible points situated, number one, on the opposite banks of a large river, on either side of a deep gorge or valley. So in case of gorge or valley, it is not possible to set the instrument midway because the lowest point is very low in case of valley. And the third condition between which the instrument cannot be set up for balancing the sides. Or if there is a condition that you are not able to set your instrument exactly between the 2 points, then in that case you have to perform the reciprocal leveling. So what are the advantages of this method? It eliminates, number one, the error due to curvature and refraction. Okay, so this error is automatically eliminated if you are applying the procedure of reciprocal leveling. Second one is collimation error, that is due to line of collimation not being exactly parallel to the bubble line. Now when there is a collimation error, the line of sight may be inclined up or may be inclined down when the bubble is not in the center. So this means that the line of collimation not being parallel to the bubble line. So this error is also eliminated by applying the procedure of reciprocal leveling. So this means that all the errors, that is the curvature error, the refraction error, and the collimation error are automatically eliminated if you applying the procedure of reciprocal leveling. So what is this reciprocal leveling? Let us discuss this with the help of a sketch. You will see on your screen. This is suppose that we have a point A here and B here, situated on the opposite banks of a large river, and the 2 points are at a distance D apart, and this is your river here. So it is not possible to set the instrument midway between the 2 points for balancing the sides. So in that case, what we'll do? First, we set our instrument on one bank of the river. Suppose it is here. So this staff is A point, which is very close to the instrument. Okay. So first we took the reading on this staff, and then on the opposite bank there is another staff. Then we have to take the reading on this point also. Okay. Now you see that here, this one is your apparent staff reading from top line to the bottom portion of the staff. So this is your apparent staff reading. Okay, and this much is the error amount, that is your E. Okay, between this line and this line. So this error includes all the three errors, that is the curvature, the refraction, and the collimation. Okay. Now we will have to calculate what is the true difference of level between points A and B, and what will be the amount of error E. What is the value of E here? Okay. So first of all, I have to take the reading from this bank of the river. Then after taking the reading, I have to shift my instrument as well as the surveyor party from this point, okay, and transfer it to this point using a boat, okay, and then set the instrument nearer to point B. And again, repeat the same procedure, okay. The first reading is taken at this point, that is your reading is C, and the opposite bank, the reading is D, and this much is the amount of error. So this one is case 1 and this one is case 2. Now using these two cases, I have to find out the correct difference in elevation between these 2 points. So let us start here. Suppose that H is the true difference of level between point A and B. E is the total error due to curvature, refraction, and collimation adjustment. So all the 3 errors are included in this here, E here. So case 1. In case 1, the true difference of level between A and B, H, is equal to, this is apparent reading here, and this is the amount of error. So B minus E will give you the correct reading at B. So this is B minus E minus of A. So will give you the difference of the two, will give you the correct difference in level between the point A and B. Similarly for case 2, H is equal to, this is C, there is no error here, and there is error here, D minus E. So this is equal to C minus D minus of E. So using these two equations, now adding 1 and 2, what we get? Twice H is equal to B minus E minus A plus C minus D minus E. So when we solve this equation, we get 2H is equal to B minus E minus A plus C minus D plus E. So E cancels out here. So we'll get here B minus A plus C minus D. So what is we get here? H is equal to half of B minus A plus C minus D. So this is nothing but a apparent difference level, okay, from point A. This is apparent difference in level from point B. So we'll take the average of the two apparent difference in elevation between the 2 points. So this is nothing but give you H. There is no error term here, E term here. So this means that the errors are automatically eliminated. Now in the second case, we have to subtract equation number 2 from equation number 1. So what we get here? So this H cancels out, 0 here. So this is B minus E minus A minus C plus D minus E. So here in this case, we have 2E is equal to this E with minus sign we have to take from the other side. So this 2E is equal to B minus A minus C minus B. So this E comes out to be 1 by 2 B minus A minus C minus B. So this is the equation for the, if you want to calculate the total amount of error, so we have to get from this relation. That is B minus A minus C minus D divided by 2. So this is your reciprocal leveling. Now next we will do some examples, 1 or 2 examples based on what we had discussed last time and in today's lecture also. So we have in this example we have to find out the difference in elevation between 2 points A and B. A level was set up on the line AB, 50 meter from A and 1300 meter from B. A and B being on the same side of the instrument. Now we are given a line, okay, AB, and we have to set our instrument which is 50 meter from A and 1300 meter from B. But the condition is that A and B are on the same side of the instrument. Suppose that my instrument is on the left side and point A is 50 meter from A, and point B is 1300 meter from B. So both the points A and B are to the right of the instrument. Okay. Now here we see that the readings obtained on the staff held at A and B were 0.435. On point A, the staff reading is this one, and point B is 3.950. So find the true difference of elevation between A and B. So here in this problem, as I told you in the class, that if the distance from the instrument to the staff is less than 200 meter, so there is no appreciable error due to curvature and refraction. So these errors are only appreciable after a distance of only 200 meters. So here my point A is only 50 meter from A. So there is no need to apply any correction for the staff reading, which is at point A. That is, this reading is correct here, 0.435. There is no need to apply this correction because the distance from instrument to the staff is only 50. But here the distance of point B from the instrument is 1300 meter. Okay, this is very large. So we have to apply the correction due to curvature and refraction to the staff reading at B, and then finally we get the true difference elevation between A and B. So let us solve this problem here. We are given distance of instrument from A is 50 meter, distance from instrument to B is 1300 meter, reading on A is 0.435 meter, and reading on B is 3.950. Combined correction, we know this formula. We have already derived in the class this formula. This is equal to 0.0673 of D square. Now again here I will tell you again that D is always in kilometers. Okay. Now let us see the results. If suppose that my D is 200 meter, this is not the part. This is not the part of this problem. I will just explain it to you. Suppose that if D is 200 meter, then what will be the combined correction? C is equal to 0.0673 D square. So D we can write in kilometers here. So this is 0.2 square. This is about 0.003 meter, that is 3 millimeter. So it is very small. So we'll see that if the distance from the instrument to the staff is 200 meter or less, so we have only 3 millimeter error in the staff reading, which is very small. So that's why we have to apply the curvature and reflection correction only if the length of sides are more than 200 meter. So therefore corrections are not applied to the staff reading at A. Now combined correction for curvature and reflection at B will be equal to again 0.0673 D square. So now here for point B, which is 1300 meter from instrument station A. So this means that when you convert it into kilometer, it is 1.3 whole square. So this comes out to be 0.1137 meter. Okay. Now I know that the combined correction is always in subtractive in nature. So the correct staff reading at B is equal to, this is the observed staff reading at B, and this is the combined correction. So this is always subtracted here. So we will get the value as 3.8363 meter. That is the correct staff reading at B after applying the correction to curvature and reflection. So this means that the true difference in elevation between A and B is equal to, this is my reading at B, and the reading at A is as it is 0.435. There is no need to apply the correction here. So subtraction of the two will give you the correct difference in elevation between these 2 points, that is 3.40. Clear? So simple problem. So let us again discuss one more problem here. An observer is standing on the deck of a ship, just sees a lighthouse. Okay. Suppose that any observer is there, which is standing on the deck of a ship in the sea, and he is just seeing a lighthouse. Lighthouse is a structure, is a house in the sea, which gives directions to the sailing boats. Okay, and there is a light on the lighthouse. With the help of that light, the ships got the directions. So the top of the lighthouse is 35 meter above the sea level and the height of the observer's eye is 6 meter. So observer is height is 6 meter above the mean sea level because he is standing on the deck of the ship and the light of the high lighthouse is 35 meters. So find the distance of the observer from the lighthouse. So you have to find out the distance of the observer which is at the ship from the lighthouse. So we have to apply here the formula of distance to the visible horizon to solve this problem. You'll see that suppose that this is the horizon here. The lighthouse is here, okay, but the light of the lighthouse is actually visible at this point, okay, and this is your observer here which is standing on the deck of the ship. So this height is given as 6 meter and the height of the lighthouse is given as 35 meter. So I have to apply the formula for combined correction and curvature. Sorry, distance to the visible horizon, that is nothing but the uh, by application of this formula, that is h1 is equal to 0.0673 d1 square. So when this one is known to me, okay, this is h1 is known to me, and I have to find out this distance, that is CA here, okay. So first we apply the formula for this one here and then find what will be the value of d1. So from this relation, d1 comes out to be h1 divided by 0.0673. Now h1 is known to me, 6 meter divided by this one. So I will get is 9.44 kilometer. D is always in kilometer and h is always in meters. So the distance from the observer to the horizon is, that is your CA distance, comes out to be 9.44. Now I have to find out the distance from point A to this point here, which is nothing but the point of the lighthouse. I know the height of the lighthouse, so I can easily find the distance, this distance. Again applying the same formula, h2 is equal to 0.0673 d2 square. So this d2 comes out to be h2 0.0673. So this is, just put the values here. H2 is 35 meter divided by 0.0673. Take the square root, you will get a 22.8. So I got D1 as 9.44 kilometer. D2 from here to here is 22.81. When we add the two, we'll get the distance of the observer from the lighthouse. So this is equal to, D is equal to D1 plus D2. So it comes out to be 32.25 kilometers. Okay. Now this is another problem. Okay, you just very simple problem. An observer at a height of 40 meter above the mean sea level just sees a luminous object on the top of the hill. The distance between the observer station and the hill is 80 kilometer. What is the height of the hill? So in this problem, you have to find out what will be the height of the hill. So in the previous problem, you have to find out the distance from the observer to the lighthouse. Here, the distance of the observer station and the hill is known to you as 80 kilometers. You have to find out what is the height of the hill, which is on the other side of the observer. So here, suppose that this is the distance from here to here is given as 80 kilometers. This height, observer's height, is given to you as 40 meter here. You have to find out, suppose that a hill is here. Okay, you have to find out what is the height of the hill. So again, I have to apply the same formula which we have applied in the previous column and then solve this also. So what is this? H1 is known. This one is 40 meter. D is given from here to here at 80 kilometer. So this is D1. Again, I have to apply this formula, same formula. So from this, I can calculate D is equal to 40 divided by 0.2673. So this is equal to 24.39 kilometers. So I know the distance from here to here. I know the total distance from here to here, that is 80 kilometers. So this distance I can easily find out by subtracting d2 is equal to d minus d1. That is nothing but 80 minus 24.39. Okay, this comes out to be 24.39. The total distance from here to here is 80. So this can easily be found out by subtracting the 2. So this comes out to be 55.6 kilometers. Now I have to find out what is the height of the hill. So again, I have to apply the same formula and find what will be the height of the hill here. So again, h2 is equal to this much. I know everything. I know d2 here. So easily we can find out the H2 here. So this is 0.0673. In place of D2, I write 55.61. Okay. So this comes out to be 208.2. Okay. So very simple. These three columns. Okay. Next, I have to solve one more problem on the reciprocal levelling now. Okay. So we are given here in this column, two pegs A and B were 750 meter apart across a wide river. So please note down the distance is 750 meter. So this means that there is a chances of error due to curvature, the refraction and the collimation. The following readings were taken with one level. So these are the readings you can take. When the level is at A, that is on the near side of the bank, okay. So these are the readings. On point A is this one, on point B is this one. When the level is at B, that is on the other side of the river. These are the readings on A and B. You are given that the error due to collimation adjustment of the level was plus 0.002 meter per 100 meter. This plus sign, the collimation adjustment error is given as plus 0.02. This means that the line of sight is inclined up. When it is inclined up, this sign becomes positive. If it is inclined down, this sign becomes minus. So here you are given that this collimation error is given as 0.02 meter per 100 meter. So you have to find out how much is the collimation error for 750 meter here. So you have to find out, determine the true difference of level between A and B. You have to find two things. First of all, you have to find out the true difference of level and the refraction correction. So let us discuss one by one. You are given that the distance between A and B is 750 meter. You also given the collimation error as plus 0.002 meter per 100 meter. With level at A, the staff reading on B is given as 2.847. Okay, this is my B reading. Now this is the diagram here. Okay, you will see that this is the staff reading at A is this one. This is the staff reading at B is this one, 2.847. Then with level at A, the staff reading on A is 1.543. This is noted by small a here in the diagram also. Then when the level is at B, suppose that this is the second position. Now here the staff reading on B, this point, which is noted by C here. So this is equal to how much? 2.622 here, 2.622, which is noted by C. Similarly, when the level is at B, the staff reading on A is denoted by small d here. Okay. Now here you have to find out the true difference of level between A and B. I already derived this formula. The true difference of level is given by 1 by 2 of apparent difference in level from the 2 points. So this is B minus A plus C minus D here. Everything is known. These readings is known to us. So I just subtract that 2 here, B minus A, this one, plus C minus D is this one divided by 2. So I will get this is the true difference of level between A and B. Now I have to find out the correction for curvature for 750 meter. Now this is the formula for curvature only, mind it. For curvature is 0.0785 of d square. Combined correction is 0.0673 of d square. So here I have to find out only the curvature here, because I did not know the refraction correction. So this is equal to 0.0785. D is always in kilometer, 0.75 whole square. So this comes out to be 0.044 meter. I know the collimation error is given as in 100 meter it is plus 0.002. So I have to calculate this in 750 meter here. So this 750 meter you can calculate very easily. This comes out to be 0.015 plus. Okay. So in 100 meter is this one. So calculate unit value here, and then finally you have to calculate in 750 meter. Now suppose that let R be the refraction here, because I have to find out the refraction. So let us start from here. Suppose that my level is at A. So what will be the correct reading on B? How much is the correct reading on B here? That is nothing but observed reading at B. Okay. Observed reading on B minus curvature. Why minus? Because curvature is always subtractive in nature. Plus R. Why plus? Because reflection is always additive. Curvature always subtractive, reflection always additive. Okay. And minus collimation error. Why minus sign? Because my collimation error is given as plus 0.00. This means that the line of sight is inclined up. So this means that error is positive. So correction will be negative. That's why this is your minus sign. Okay. And the true staff reading on A is already given as 1.54. Okay. So I have to find out the true difference of level between A and B. That is already calculated in this step. This is 1.25. So starting from this reading here, reading at B, I have to find out what will be the correct difference relation between A and B and then equate to this value here. So this is equal to the level at B when the reading is at B. So this is the correct apparent reading at B, 2.847. It is given here, 2.847. This is my curvature with a minus sign, plus R, that is reflection, minus collimation, that is given as minus sign because of correction, minus 0.015, minus the staff reading at A, that is 1.54. So when you have to equate it to true difference of level between A and B, which is 1.25. So when you solve this equation, only unknown is R. So we get R is equal to 0.007 meter. So simple problem. Okay. So in this problem, we have to calculate two things. First, we have already calculated this two difference of level between A and B. Then next, you have to find out the reflection R. For that, first we have to calculate the curvature correction. We are already given the collimation error, so we have to calculate in 750 meter, and then by applying the principle that the true difference of level at B will be equal to the observed reading at B minus curvature plus reflection minus collimation, and then equate it to the true difference of level between A and B, you will get the reflection correction. So this is your second problem for reciprocal leveling. That is your, again, the level at A and B, the staff readings are given to you. Distance between A and B is 800 meter. RL of A is 450 meter. RL of point A is given to you. Okay. You have to find out the true RL of B. What will be the RL of B? Second, you have to find out the combined correction for curvature and reflection. Very simple. And third, you have to find out the error in collimation adjustment of the instrument. Now here you will see that the staff reading on A is less and on B is more. So this means that there is a fall from A to B. Here it is reading is less, here it is more. Again there is a fall from A to B. So let us solve this problem. You have to find out the true RL of B. So we are given when the level at A, the staff reading on B is given as this much, 1.630, that is a small b here. When the level at A, staff reading on A, that is a small a, is 1.030. From B, this is the staff reading, that is your C value, and this is your D value. So we can easily find out the true difference of level between A and B, again by the previous formula, B minus A plus C minus D divided by 2. So all the quantities are known to me. So just this is my true difference of level between A and B. Okay. So you have to find out what will be the true RL of B. The RL of A is given to you. So how to calculate the RL of B? RL of A is 450. Okay. Now here from A to B is fall. So this means that I have to subtract the true difference of level between A and B. I have to subtract it from here. This is minus sign here. Okay. Because there is a fall from A to B. If there is a rise from A to B, then I have to add it. Okay. So this is the RL of B. Second, I have to find out the combined correction for curvature and reflection. Very simple. This is my formula, 0.0673 D square. D is always in kilometers. I know D value as 800 meter. It is 0.8 in kilometers. So this is my value, 0.043 in meter. That is the combined correction. Now, last thing I have to find out error in collimation adjustment. So E is known to me. E is given by this formula 1 by 2 B minus A minus C by 2. C minus D. Now, what is the difference between previous and this formula? Only this difference here. In place of in H value, when you have to find out the true difference value, that is your H. So here is the plus sign. When you have to find out the error E here, this is your minus sign. The other quantities remain the same. So this is E is equal to, everything is known to me. Okay. So I got, this is the total error. E is nothing but your total error. Error due to curvature, the refraction, and the collimation. So I know two things. Error due to curvature and refraction is known. So I have to find out that very easily what is the collimation adjustment. So combined correction is known to me. Combined correction means due to curvature and the refraction. Therefore, error in collimation adjustment is equal to 0. This is my total error minus of this one. So this is my error in collimation adjustment. So this is all about these problems based on reciprocal leveling. I hope that you understand these problems, and you just go to the video several times, okay? And if you have any difficulty, okay, you can ask me on your WhatsApp or just mail me, okay, on my mail ID. Okay, thank you so much. So in the next lecture, we'll discuss some more topics, some new topics of surveying. Okay, so that's all about. Thank you very much.